Good morning, my YouTube viewers. It's Crystals here. I'm here this morning because I wanted to do another video, and on this other video that I'm doing, basically what I'm doing is I'm doing an exploratory data analysis on the Galton data set, but what I'm doing is rather than using Python, and I can't really use R because R will not allow, my compiler in R will not allow me to import the data file, and so it's not practical for me to use R. So I decided to do it again. I've decided to do an exploratory data analysis again, but I'm going to do it in Excel and Python, because most people have Excel. Most people have Excel at work, but they might not have the most current version of Excel, because like the most current version of Excel also has Python. But if you pay for Excel, then you'll get Python, because I pay for Excel. Basically, what I'm going to do is we're going to do an exploratory data analysis in Excel. You can see on my screen right now, I'm in the formulas column, and in the formulas column, it has a little blue icon that says Insert Python. What that does is that allows you to insert Python formulas into a cell in Excel. The great thing about Python is in Excel is there are a lot of things that Excel won't do, or it won't do it very well, or if it does do it, it does it in a very cumbersome manner. And because of all of the libraries that are inherent in Python, you can do it more easily in Python than you can in Excel. So that's the great thing about having Python in Excel, because some of the things that would be really hard for you to do in Excel, you can put Python in your spreadsheet. And that's what we're going to do, and I'm going to go over that with you. So the first thing that we have to do is the very first worksheet in the very first sheet in the workbook has to be your import your Python libraries. And so Excel knows to look in the first worksheet for that. So what we do is we have to import our libraries. So on this cell A1, I imported Pandas, NumPy, Matplotlib, and Seaborn. And cell number A2, I imported stats models. So we've got the main libraries imported into Excel, and basically what I did was I imported all of the libraries that I used when I made the program in Python just into Excel. So we've imported our libraries, so we are in a good position to be programming code into Excel. What I would recommend that you do is you just save that first page just for the libraries and nothing else. So now we've got the height data and the row data, and so basically I went onto the internet and I found some data that I thought was acceptable, because there's lots of data on the Galton data set and lots of data sets on the Galton data set. And so I just picked one that I liked and I did it. And what I did was, on the web page where the data set was, I just went up to the very top left corner and I entered Control A, and then when I entered Control A, that blocked off all of the data, and then I went onto the Excel spreadsheet and I went to A1 and I typed Control V, and that copied everything down. So So I feel that I need to tell you something about me personally. Sometimes I have problems with my words, and I looked it up, and it's a type of aphasia. And they say that you can have it after you've had a stroke. So I'm 63. I'm not in good health. So maybe there's a possibility that I had a stroke and I didn't know it. Because you can have strokes and not know it. So there's a possibility I maybe had a stroke and not know it. And but they say that it doesn't affect your intelligence. It just affects your speech, not being able to find the correct words. So I feel that, if you've been watching my videos and subscribing to me, if I get a word mixed up or something like that, I'll always correct myself, but I just want you to know, to be a little bit understanding that it doesn't affect my intelligence, it just affects my brain. And another personal thing, today this week I was walking to the bus stop, and this lady that I know who she is. She's an acquaintance, and she's a bit odd. And she asked me, she said, "Can we cross the street?" And I said, "No, you can't." She said, "What about now? Can we cross the street now?" And I said, "No, you can't." I said, "Well, yeah, you can." And she said, "Pray for me." And I said, "Why? What's happened?" And she said, "My brain's not working correctly." So it can happen to anybody. I'm not sure exactly how old she is, but she said her brain wasn't working correctly. So it can happen to anybody. I don't know how old my viewers are, but I just felt that if I get a word mixed up or something like that, at least you'll know that maybe I had a stroke and I didn't know it. It's a type of aphasia. And that's also what Bruce Willis has. Bruce Willis has aphasia as well. So we'll move on to that after we've talked about my personal stuff that relates to this video. I'm not just telling you my personal things. It relates to me making videos. And we're going to move on to the next page. And on the next page, what we have done is we have taken the data, and we've converted it to tabular form. And how you do that is, I think you go to data and you click on text columns. And then when you click on text columns, then what it will do is it will take you through a series of questions, and then you answer those questions, and then it will take all of the text that's in column A, and it will convert all of the text with the delimiters into all of the other columns. So we've got family, father, mother, height, gender, binary gender, and kids. And the thing is I had to add binary gender to it. And the reason why is because the computer doesn't want to see male or female. And since the computer doesn't want to see male or female, I had to make it a binary gender so the computer would work with it. And so I put this program in here: if E2 equals F0, 1. So that means if it's a male, they get a 1, and if it's a female, they get a 0. And so I don't want anybody to get upset and say it's not good about women to give women a 0. I just did that. And so if it's a male, it's a 1. If it's a female, it's a 0. And then I did some charts on it as well. But what we're going to do is we're going to do the analysis in Excel. We're going to do the analysis in Excel. I've got lots of analyses going on. So number 1, is there a correlation between the number of children and height? So we're going to use the CORREL function, and the correlation is negative 0.12691. So there's no real correlation between the number of children and the height. Number 2 is, what is the correlation between the child's gender and height? So again, we use the CORREL function, and you see that the correlation is 0.71. So that means that's a very high correlation between the child's gender and height. That's probably the highest correlation that there is. Number 3, what is the correlation between the father and child's height? So that's, we use the choral function again, and it's 0.27. So other than the child's gender, the father has the highest correlation in the height. Number 4, is there a correlation between mother and child's height? And we use the choral command again, and the correlation between the mother and child's height is 0.2. So the father has greater correlation than the mother. So that's interesting. So what that's telling you is that children generally get their height off the father. It says, what is the father's mean height? We're going to use the average function to get that, and it's about 5'9" is the father's mean height. And this was in the 1800s. This data was taken in the 1800s, so people were, a bit on the tall side even on the 1800s, because 5'9" is an average height, and my boyfriend is 5'9". And then so it asks you, what is the mother's mean height? Again, we're going to use the average function for that, and the mother's mean height is about 5'4". And I used to be 5'5". I'm not sure how tall I am now. I'm about 5'4", 5'5", because the older you get, when you reach your 30s or definitely the 40s, the older you get, the cartridge in your spine starts to deteriorate, and when the cartridge in your spine deteriorates, you get shorter. So I was 5'5.5", but I'm not anymore. What is the father's median height? And then this one we use the median function. And if you don't know the difference between the mean and the median, the mean is you take the sum of all the heights and then you divide that into the total rows that you use, and that's where you get the mean. But the median is the you sort it, you sort all the heights, and then you take the element that is in the center, and that's the difference between the mean and the median. So in that 69 inches, what the next question is, what is the mother's median height? 64 inches, so that's 5'4". So you can see that the mean height is just slightly more than the median height. And the reason why is because the median height, they are just plucking out the middle element. And that's how you get your median. And they used to use, they used to calculate median by hand, and it was a lot more difficult to do, but we don't have to do that anymore because you've got median in Excel, and then median will do that for you. And there is a formula for calculating median, and there's one way to calculate it if the number of elements is odd, and another way to calculate it if the number of elements is even. If the number of elements is odd, then what you do is you take the middle element, and that's it. If the number of elements is even, then you take the two middle elements, you add them together, and then you average them. And that's your median. Number 8, is there a correlation between the mother and father's height? So I just wanted to see that if there was a correlation. It's a very low correlation. It's 0.07. And I think what that means is women are going to naturally be attracted to a man that's of a certain height. That's what I think that means. But it's a very low correlation. And we use the choral function for that as well. Now we ask, what is the son's mean height? And so we use the average function for that. And again, what you had in the gender, you had boys and girls in the gender. So we had to use sum if. So the sum if is if it's a male, and then you add up all of the values, and then you divide it by the number of male values. So it's 69.22. So that's 5'9" as well. So the son's height average was very close to the father's height average. We asked the same question about the daughters, and we used the same formula for the daughters. So like it's a sum if function. So if the gender is female, then you're going to sum it all up, and then you're going to count it if the gender is female. And then that average height is 64, which is 5'4" as well. So the daughter's heights are very similar to the mother's heights. So now ask the question, what is the son's median height? Well, we don't have a median if function. So what we do is we use median function, and inside the median function we use if. So if the gender is male, then you'll get the median height, and you use the median function first, followed by the if function. The next question is, what is the daughter's median height? That's the same formula as the formula above, except instead of asking for M for male, we're going to ask for F for female. So you get the median if the gender is female, and then you calculate the median of that for the children's heights. I thought this would be interesting to ask. Number 14. What is the maximum number of children in a family? That's going to be 15. That was interesting. And then 15. What is the distribution of the number of children in the family? So you see the distribution is very similar to normal, except you've got an outlier. So you've got like a few people with big families. And then I used a histogram for that. So what you do is you take the height column, and then you go to insert, and then you go to recommended charts, and then in recommended charts, if it's not in recommended charts, you'll find the histogram. So you do a histogram on that, and that will give you the distribution. The next one is, what is the distribution of the father's height? And that's, again, we created a histogram, and it looks sort of like a normal distribution, but you do have some outliers there. So you do have one man who was 5'2", and one man who was 6'6". So the thing is, or maybe more than one, but a couple. And again, what you have to do is you go to the father, and then you select on that column, and then you go into insert formulas, and there should be a histogram in the recommended formula, and that's what you use. So now we're going to ask the question, what is the distribution of the mother's height? And again, we do it the same way that we did the number of children in the family and the father's heights, except for this time we're going to go to the column that relates to the mother. And you'll see that this one is not, it looks sort of like a normal distribution, but it's quite varied. So you can see that the women's heights are more varied than the men's heights. So that was it for our analysis, but I thought to myself, there were other things that I could do, because Excel is a bit limited in the types of graphs that it can make and everything. But what I did was I did a regression. And then so what this regression is, this looks sort of like it's similar to stats models. And how you do the regression is you go into data, you go to data analysis, and then you click on the regression, and then you click OK, and then it will ask you a series of questions, and you answer those questions. But here we've got the regression for this data. And then so your Y variable is going to be the height of the children, and your X variable is going to be your mother and your father's heights. And then so we've got our ANOVA, and you've got your intercept. So we've got the intercept and the mother and the father. And if you wanted to include the number of children in the regression, you could do that, but it would be a little bit more difficult. And what you would have to do is you would have to take the number of children and you would have to move it over to like maybe A1. So it would be lumped in there with the father and the mother. So it's going to be a little bit more difficult to include the number of the children in there if you wanted to use it. But when we did the correlation, we found that the number of children has not very highly correlated at all. And then we've got the residual output. So that gives you your residuals. So that's very interesting. So if you're interested in doing regressions in Excel, this tells you how you can do a regression in Excel. And now what we're doing is we're in our Python visualizations. And I've done 3 visualizations in Python. And so if you watch my previous video when I was doing a exploratory data analysis in Python using Google Colab, then you will be familiar with these plots. And so the first thing that I didn't want to do all the plots because I was up last night doing it, and it's a little bit more difficult to work with when you're accustomed to working with Python in a Jupyter notebook. It's more different working with Python in Excel, but I did it. I was up last night working on it. So the first image we have is, let me just say, so we're going to create a density plot of the mother and the father. So that's the first one we did. And so what you have to do is I created a variable called both, and then I went over to the page that had these data in it, and I got the both is B1 to C899 and headers is true. And then so I created a density plot using C4 and KDE plot, data equals both, and then the X label is height of the mother and the father. And so you can see that. You can see that the plot is very small, but you can see that the mother is going to be amber and the father is going to be blue. You can see that the mother is shorter than the father. The mother is about 5.2 inches shorter than the father. And then so the next one, we've got another one. And we're going to create a density plot of the children. So the data is going to be D1 to E899. And D1, I think, is the children, is the gender, and then the E is the height of the children. And then it's so we create the data, and then we create a density plot. So SNS KDE plot. Data equals data. X equals height. So that was the height column. And U equals gender, and that was the gender column. Because in the gender column, you had 2 categories. You had a male and a female. So what that has to do is it has to select out the males and the females. And so what you have here on the resulting diagram, it's sorted out the males from the females. So you've got the females in amber and the males in blue. And again, you can see that the females are shorter than the males, about 5 inches shorter than the males. So the next one we have is I just did one residual, and I just plotted the residuals on a regression line. So I plotted the graph. X equals the father's height, and let me see, X equals B1 to B899. That's your father's height. And Y equals D1 to D899. I think that's the children's height. And then we converted that into a NumPy array. And then after we converted it into a NumPy array, we had to flatten it. And now we're going to plot the scatter plot. So X is your father's height, Y is the child's height, and the color is going to be green. And then AB equals NP polyfit XY1. So we're using the polyfit to make a straight line, to make your regression line. And then you do your plot X, AX plus B, and that's your formula. That's your regression formula. And then so we're going to plot the x-axis is the father's height, the y-axis is the child's height, and okay, and then we're going to show it. And as you can see, that there is your try to do it again. I hope it works. So there you've got the regression line with the father and the child's height on the regression line. So I just wanted to show you that as well and show you the code for that. So that's it. That concludes this exploratory data analysis, where we have carried out an exploratory data analysis in Excel and Python in Excel, because sometimes with these charts, I don't know how to put a double chart in Excel. You might be able to do it, but I don't know how to do it. And it's some of the things that you do, and especially it's just easier to use Python and Excel on some things. So what I would recommend that you do, which is what I've done in this instance, is you use Excel when you can, because you're using Excel. And then you use Python in Excel when you can't find an appropriate formula to do Python in Excel. And that is what I would recommend you do. There is one thing that you could do, is you could take the parent's height, and then you can make a chart on the parent's height. But again, I think that's going to be a bit difficult. I'm not sure if you can do it. I'm not sure if you can do it, but let's just try it out. So the recommended charts don't look very good. So the recommended charts don't look very good. Here's your XY scatter plot, where the father is blue. You can barely see it. The mother is amber, and the child's height is green. And so you can do a scatter plot on that. And then so you can do that. So that's one thing you can do if you want to do it. But the scatter plot, it's just a big blotch, isn't it? So I think that concludes this video. We've talked about everything that I intended to talk about in this video. I'm sure that there's lots more to talk about. I'm sure there's people who are much better on Excel than I am who might say, oh, well, you can do these double charts this way, but I haven't been able to find. I don't know how to do it, and I thought this would be a good opportunity to cover Python and Excel as well. So thank you so much for watching my video. If you like my video, please like and subscribe, and thank you again for watching my video, and I look forward to communicating with you very soon in another technical subject.